We'll look at lesson 4.5 is equations with rational numbers. So we've done some solving equations where we've added, subtracted, multiplied, and divided. One thing that's been true with all the problems we've worked so far is we've always been working with whole numbers. In real life, things are not always whole numbers. Things don't always work out evenly, perfectly. So in this lesson, we're going to talk about with rational numbers how we would solve. The steps are going to be exactly the same as what we've been doing. It's just that we will have some fractions and decimals that we'll be working with on these problems. So example 1, we have a 6-foot piece of fruit snack is cut into 2 pieces. What is the length of the shorter piece of the fruit snack? So they've drawn a picture here, and you can see the one piece is 3 3/4 feet. We're trying to find that other piece. So a couple ways we could do this. One way, what they did, they drew a bar diagram. So they said, well, it's 6 feet altogether. The longer piece is 3 3/4 piece, 3 3/4 feet, and we're trying to find what that shorter piece is. So they said 3 3/4 plus x equals 6. That would be one way we could set up an equation for this. Another option you could think of, you could say, well, it's 6 feet total. 3 3/4 feet is the longer piece. If I just subtract that from 6, that will give me the shorter piece. So those are 2 different options, 2 different ways we could write an equation for this. If you did it the way they did, we would be solving the equation kind of like this, only we would probably write ours underneath. You can see they are adding here. So they're adding means we need to subtract. So they subtracted 3 3/4 from both sides. Now, in order to do that, 6 minus 3 3/4, we have to borrow or rename the 6 as 5 4/4, and then you can subtract and you get 2 1/4. So 2 1/4 feet long. If you did the other equation, this one would already be set up for you. And so this is already ready to go. The variable is by itself, so it's just a matter of subtracting, and you would get the same answer, 2 1/4 feet. So going off of our previous example, if we cut the shorter piece of fruit snack from the example into 2 pieces, the longer of the 2 pieces is 1 3/8 feet long. Complete the bar diagram to represent the equation, then find the length of the shorter piece. So from the example above, we found out that the shorter piece was a total of 2 1/4 feet long. So if we were doing this bar diagram, 2 1/4 feet is the total. And from what we just read there, they told us that the longer piece of that is 1 3/8 feet. And we're trying to find that shorter piece here. So that would be a bar diagram way of showing that. Then they've got an equation off to the side here that we can work off of. They said, you know, these 2 pieces together add up to 2 1/4. So they add up to 2 1/4. So just like we done earlier in the chapter here, we're going to do the opposite operation. So on this one, over with the variable, what are they doing? Adding, so we would need to subtract. Good. They're adding 1 3/8, so we'll subtract 1 3/8. So if we subtract 1 3/8 on the left side to keep our equation balanced, we also need to subtract 1 3/8 from the right side. In order to do this, going back to things we've talked about with fractions, if we add or subtract fractions, first we need to
do the simplification process.
get a common denominator here, which would be 8. So our top fraction will need to multiply both of those by 2. So 2 2/8 minus 1 3/8. Can we take 3/8 away from 2/8? No, so we're going to have to borrow. Good. So to borrow, we're going to change our 2 to a 1. We're borrowing a whole. Looking at our denominator is 8. So if we have a whole, that's the same as how many eighths? 8 eighths plus the 2 we already have gives us 10. Good. Now we're ready to go. 10 eighths minus 3 eighths would be 7 eighths, and then 1 minus 1 is 0. So this would be our 1 and 3 eighths again, and then our answer would be 7 eighths. Okay, so the shorter piece is 7 eighths of a foot long. Example 2 says use inverse relationships to solve each equation. Inverse relationships just meaning basically we do the opposite operation. Okay, inverse and opposite are used interchangeably. So if you look at part A, we can see on this problem over with the variable they are. What's going on? Operation on the side with the variable. They're subtracting means we need to. Okay, so just like we done before, just the only difference is we have fractions here. Okay, part B, what the book did is okay. They're basically using the definition of reciprocal. A number of times its reciprocal equals 1. So they're saying the reciprocal of 3 eighths is 8 thirds. So if we multiply 3 eighths by 8 thirds, we get 24 24ths, which is equal to 1. And 1n is the same as n. Okay, kind of interesting. And then they did the same thing on the other side. So you're welcome to use that method if you want to. If you don't want to think about a different way of doing the problem, you could say that the n is being multiplied by 3 eighths, and we could divide. So you could just say, you know, they're multiplying by 3 eighths, we'll divide by 3 eighths on both sides. Opposite operation like we've been talking about. And then remember, for division is just keep, change, reciprocal to work that out. So we keep our first fraction. We change the division to multiplication, and then reciprocal, which is like flipping that second fraction. Okay, and if you'll notice, we are doing now the same thing that they did on their problem, 3/4 times 8 thirds. If you look at part C, I didn't need to cross out this whole thing here, but this is okay already how it is. We can see the variable is being divided by 5, so we would just multiply by 5. So this step here isn't really necessary. What they did here is actually okay. So we can just go ahead and multiply because they're dividing. Just a quick refresher about some rules about working with fractions. When you're adding or subtracting fractions, you have to get a common denominator. When you are multiplying fractions, we don't need a common denominator. We'll just multiply the numerators, multiply the denominators. And then dividing fractions, we just talked about keep, change, reciprocal, and then we change that into a multiplication problem. Alright, so if you look at the try it here, we are solving the equation. So the equation, just the middle part here, the equation is 5/9 y equals 25. We are solving the equation for y. We're trying to figure out what y would be equal to that would make this equation work. So there's a couple ways we could do this problem. One option is the way the book showed you with the reciprocal, if you look back on example 2 part B. The other option is you can say the 5/9 and the y are being multiplied. They're being multiplied, so we would want to divide. So to solve this, we could do 25 divided by 5/9. When we do that, the 25 we could put over 1. Okay, and then for division we just talked about is keep, change, reciprocal. Keep, change, reciprocal. Good. So this is going to become 25 over 1 times 9/5. So 25 times 9, we could think about if we had 9 quarters, that would be $2.25. 1 times 5 is 5. And then it's just a matter of dividing that out. So 225 divided by 5, 5 goes into 22 4 times, good. And 5 goes into 25 5 times, good. So our answer would be y equals 45.
So you pretty much just did 5 times 9.
Example 3, Molly bought these oranges for $7.15. She paid the same amount for each orange. Write and solve an equation to find M, the cost of each orange. So if we count it out there, there's 13 oranges total. They did a bar diagram, and then they came up with the equation 13 times M equals $7.15. Another equation, we could do $7.15 divided by 13 equals M. Take the total cost divided by how many oranges would give us the cost for one orange. We work that out, would be 55 cents for each orange. The try it is basically the same idea there. You could just do $3.60 divided by 8. It's basically just finding a unit rate, how much we paid for one apple there, just like we did with the oranges. Example 4 talks about inverse relationships. So that's like opposite operations again. So you can see on part A, we're trying to solve for M. Over with the M, they're adding, so the opposite operation we would need to subtract. Part B, they are subtracting with the variable, means we need to add. And part C, they are dividing, means we need to multiply. Okay, on the try it, we need to come up with an equation and solve it. So Carmen spent $12.50. Just to make it a little simpler here, they could have added a word just to be a little more clear. Carmen spent $12.50 total for a new notebook and compass. So altogether, that's what the cost was there. Right. Notebook cost $6.35. Write and solve an equation to find C, the cost of the compass. So think about what your equation would be that we could figure out the cost for the compass here. So a couple ways we could write our equation here. One option, we could say our total cost, $12.50 minus $6.35 equals C. Even though this isn't how we would write the problem to work it out, if we're writing an equation, we want to write it horizontally. So we would write it like that to start with, and then we would write it vertically to work it out. Okay?
I did $12.50 minus $6.35 and got $6.15.
Good. So we would have to do some borrowing here. $6.15 would be our cost for the compass. Okay? Another option you could do would be C plus $6.35 equals $12.50. And if you did the equation that way, you can see over with the variable they are adding, so we need to subtract. Good. And then we would be doing the same exact thing as we just did. Okay? Key concept is just going through again the process of doing the opposite operation. Top left, they're adding means we need to subtract. Subtraction, they're subtracting with the variable means we need to add. Next one, they are multiplying, we would divide, I would say a little bit different than the book there. And then they're dividing, so we would multiply.